Okay, this is a continuation of section 2.1 for MAC1105. We were on these diagrams, these graphs where there were a mixture of problems that sort of reviewed all the concepts in the entire section, namely domain and range, X and Y intercepts, as well as evaluating at specific X values. So we had looked at this graph and saw that the minimum X value and the maximum X values, which are the domain, went from -5 to 5. There are X values in between, but this is X min, X max, and those are the values that are used to describe the domain. Likewise, on the range we use the Y values, maximum Y value being Y, that's the maximum height on this graph, and the minimum depth is -4. So the range of values that describe how high and how low the graph go is from -4 to 4. And then we were also asked for the X and Y intercepts. This graph had several X intercepts, -5, -3, -1, and then 1, 3, and 5. So all of those are considered X intercepts. They're just the X coordinates of points that are on the X axis. Likewise, the Y intercepts are the Y coordinates, and there may just be one, there is only one in this particular graph, for any point that's on the Y axis that's on the graph. So we saw that there was only one y-intercept, one place where this graph hits the y-axis, and the y-coordinate happens to be 4. Then we went on to evaluation. So we were going to evaluate this graph at an x value of -2, at an x value of 0, and an x value of 4. When you evaluate, as in the other problems, you go to the X value first, if that's what they're giving you, because sometimes they can give you the Y value. Go to the X value first. Here it would be -2. And then from that X value, you'll have to either move up or down to get on the graph. So here you'd have to move down. And when you finally do get on the graph, then you want to slide your vision over to the Y axis to see what that Y partner is. So here it would be -4. Likewise, if they ask you to evaluate at 0, start at an X value of 0, then travel either up or down, whichever way you need to go to hit the graph. We have to go up in this case. And when you hit the graph, observe the Y value. Now for this particular X value, when you do hit the graph, you're right on a Y value. So this 4 is the Y partner that goes with an X value of 0. For the X value 4, slide over to 4. You have to travel up to hit the graph. And then you want to know what is the Y partner associated with this. So slide your vision over to the Y axis and you're on 4. So that is the Y partner of X equal to 4. All of these can be written as points. The X value is where you began, and then the Y partner that's associated with it. This can be written as 0, 4. This can be written as 4, 4. That's called evaluating a function. Likewise, this problem below was also a review of all the concepts taught in this section: domain, range, intercepts, and evaluating the function. So again, domain is how wide the graph is. From what minimum X value to what maximum X value does the graph travel? We're talking about the X's. So if you think about the X's that this graph travels through, it starts on an X value of -1, and then it continues indefinitely across the X axis all the way over to positive infinity. This arrow means it doesn't stop. So your X min, the very smallest X value that this graph travels through, is -1, and I'm using a bracket because it's a colored in point, meaning include that endpoint. And then it travels over all the X values and continues traveling through positive infinity. Infinity symbols always get parentheses around them. Range, that means how high and how low does this graph go? So it is with respect to the Y values. That's what a range question's about. Okay, so this graph goes as low, that would be the Y min, as 0. When you're on the X axis, that's considered a height of 0. So it goes from 0, and then I know that this graph looks like it flattens out, but actually from this level of y equal to 0, it kind of flares ever so slightly up, up, up. It's just that, you're only seeing part of it, but it does get wider and wider and wider as it climbs upward. So it is said that these y values start at a level of y equal to 0, and then they go up, up, up to positive infinity. X-intercept, remember that's a point on the x-axis, and you're only giving the x-coordinate of that point. So the x-coordinate here would be -1. Name the y-intercept. The y-intercept would be a point on the y-axis, but only give the y-coordinate. So here is the point on the y-axis. You're only given the y-coordinate, which is +1. Okay, this time they want you to evaluate at y equal to 2. So unlike what you did up here, where you always started at a specific x value, because this number indicated right after the function name is always the x value. Here they have not given you that. Here they want you to start on a specific y value and then tell what the x partner is, so the opposite of what you did in the previous problem. Okay, so look for y is equal to 2. Remember, no matter what they start you with, you go to that number first, then travel till you hit the graph, just like you did with when you were given the x values. Travel till you hit the graph, and then find the partner, whether it be x or y you're looking for, that is associated with this value that they've given you. So first go to y is equal to 2. Travel till you hit the graph. Right there. And then find the x, drop your vision to the x-axis to see what the x partner is that was associated with this y value, which is also 2. Okay, so x is equal to 2 when y is equal to 2 according to this function. And you can write it as a point if you'd like, x value and the y value. Moving to the next page, we're comparing two graphs, so we're going to be placing two graphs. You can do these by hand or by graphing calculator. And we're going to be looking at and describing what kind of shift is happening with respect to these two functions when we compare them. So I want you to understand the difference between what you're being shown here. This is just going to be the same shape as this. Notice that f of x is x squared, and g of x also has x squared in it. This just has an additional of 5 that's being added. Here, in this second problem, they're both x squared. This has a square on the x, this has a square on the x. Only here there are extra numbers included in the parenthesis with the x and also on the outside of the parenthesis. Here there is only a number on the outside, no parentheses at all. So I want you to understand that when you're looking at a number that's included with the x inside a parenthesis, that is known as a horizontal shift. All horizontal shifts act on the x value, and you are to always, whenever it has to do with a horizontal shift, and only when it has to do with a horizontal shift, you are going to switch the sign before performing the horizontal shift. And I'll just use HS for horizontal shift. It's just too much to write out. Before performing the horizontal shift on the parent graph, I'll show you what I mean. Whereas when you have a number that is not inside the parentheses with the x, that's known as a vertical shift, which I will just abbreviate VS. You do not switch the sign for that. So you would use as is. Use the sign as given. It's just horizontal shifts that you have to switch the sign. Okay, and you'll see how I use them when I get to that problem. Let's start with this graph right here. If I wanted to do a simple parent graph, a parent graph is a graph that has no frills, nothing's added, you're not multiplying it by anything. So I'm going to do a little simple XY table. I think I'm going to evaluate this at a negative number, at 0, and then I'll also evaluate it at the positive counterpart for this x value. So -1, I'll use +1. And when you evaluate, as we've learned in other sections, you're simply plugging in whatever you've chosen for x. It is your choice. You could use bigger numbers if you want. You're just plugging it into the function. So right now I'm looking at the function called f of x is just equal to x squared. So when I plug in -1, remember whether you square a negative or a positive, it comes out positive. So when you plug in -1, it's -1 times -1, that's +1. So we have one pair to plot. When you plug in 0, that's 0 squared, that comes out 0. When you plug in 1, 1 squared is 1 times 1, you get a 1, plot these points. -1, 1, 0, 0, and 1, 1. Try to understand that from the shapes that were presented to you earlier, that this is a parabolic shape, so that you're not connecting these things in some shape that shows very clearly that you have not familiarized yourself with the shapes that you are going to be graphing over and over and over again. This course has a lot to do with graphing, quite a bit. Okay, we're doing the parabolic shapes for G of X as well. It's just that what we're going to do here is, again, what I want you to notice is that that's not a horizontal shift. This is a horizontal shift when the number is inside a parenthesis with the X, and then the way you get the graph to horizontally shift is that you switch the sign. So in other words, if I was going to do a horizontal shift in this problem, I would switch the sign and use that +3 on the X's in the new graph. You'll see what I mean when I get to it. But if you are given an extra number and that number is not inside the parenthesis with the X's, instead it's, just not inside the parentheses, it's a vertical shift, which means it acts on the Y values. So this number that you are seeing in this problem that we're working on right now, this is not inside of a parenthesis. Therefore, this is a vertical shifter. You use the sign as is. Don't switch it. You only change it when it's a horizontal shift, and you use it on the Y values. And let me show you what that means. So we are going to vertically shift this shape 5 units, and that vertical shift will take place on the Y values. So I'm going to create another table. Only this one's going to be for G of X. And you could just plug right into it if you want to. It's just that it's going to cause you more work, or you can understand what a shift is. Number that's inside parentheses, you'll do it on the X. You will perform that shift on the X. And when it's not inside parentheses, you'll perform the shift on the Y's. So if the only thing that I'm changing is the Y's, that means take these X's and leave them as is. But the Y value, see, you're working right off of this table, which you've already created by plugging values into this function. So I'm going to add 5 to each of these. So add 5 to this, you get 6. Add 5 to this, you get 5. Add 5 to that, you get 6. So when you go to graph that, you're going to be graphing something that is shifted 5 units up, but you'll see as you go to graph it. So we're going to go -1, but instead of at 1, we're going to be all the way at 6. Then we're going to plot 0, 5, which is right here. Then we're going to plot 1, 6. See, notice that this graph that I am plotting right now has the same shape, but it is vertically. Vertical is up and down. This is shifted 5 units up.